Of course, if you haven't done so, pause the video and reattempt before listening on. In part A, we are asked to calculate the current that this waffle iron carries. And in the question, we are given a power value as well as a voltage. It's important to understand that the power would need to first be converted into watts. So let's get that out of the way. We know that the power is equal to 1.00 kilowatts, but the standard unit is watts. And it turns out, of course, that 1 kilowatt is 10 to the power of 3, or 1,000, watts. So if we perform this conversion, the kilowatts cancel out. We have 1 multiplied by 10 to the 3, which would be 1 times 1,000, so we end up with 1,000 watts. The voltage is given in the standard unit of volts, so we're all set there. Let's take a look at the equation that relates power, current, and voltage. We know that power is equal to the product of the current and the voltage. What we want to do is solve that equation for the current. So let's recopy the equation for part A down below here. Current is symbolized by I, so to solve for the current, we'll divide both sides of the equation by the delta V value, which is basically the voltage or the potential difference if you prefer. And we can see that the power divided by that potential difference is equal to the current. So we'll take the power value of 1,000 watts, and then we'll divide that by the potential difference, or voltage, which again was 1.2 times 10 to the power of 2. And that's in volts. On a calculator, you might want to wrap this quantity in parentheses, otherwise it may cause an error. When you divide these two quantities, you get approximately 8.33 as the value of the current, and of course the standard unit of current is amps. So this would be the correct answer to part A of the question. In part B, we were asked for the resistance of the waffle iron. We know from Ohm's law that the resistance would equal the potential difference divided by the current. So let's copy that equation down here. Again, the potential difference was 1.2 times 10 to the power of 2 volts, and then we divide this by the current that we just obtained of 8.33 amps. And when you work this out, you should get about 14.4, and the standard unit of resistance is ohms. So this would be the correct answer to part B.